I'm even louder. So, hey, my name is Tyler. I look after developer relations at ClickHouse, which basically means I have the opportunity of traveling around the world and telling the story of software that other people built. And the question at a meetup is always, where do you start? Do you start at the very beginning with what is ClickHouse? Do you start with the roadmap? Do you start with something else? And so I'm going to give you a little bit different presentation than I've ever done before, where I'm just going to share some of my favorite features in ClickHouse. But before I start that, how many of you are familiar with ClickHouse already? Cool, I see some hands going up, rad. I'll give you a very brief introduction then before we dive into the favorite features, but to be honest, the best way to become familiar with ClickHouse is to play with it. I think that's true of any database, but of this one in particular. As Rana said, I've been traveling a lot. This is my third week on the road. I'm based in Amsterdam, but was in London, and then took a flight to Amsterdam, and then took a flight to Singapore, and then to Sydney, and then to Perth, and then back to Singapore, and then to Jakarta, and then back yesterday. So I apologize in advance if I forget something. I'm not entirely certain where my brain is at the moment. So for those of you who don't know, ClickHouse is an open source, column-oriented, distributed OLAP database. And those are a lot of descriptors that basically say, when you have data and you need to get insight from it quickly, ClickHouse is a very interesting thing to try. It was developed in 2009, open sourced in 2016. We became a company about 3 years ago. A cool thing about ClickHouse is that it speaks SQL. It's really good for lots of writes. It is distributed. It's highly efficient in terms of how we store the data. It's designed for very fast queries, and regardless of what others may tell you, it does support joins and lookups. I only have about 15 minutes. I was going to walk through the roadmap in a bit more detail, but instead what I'm going to tell you is our roadmap is publicly available, and it's at that GitHub link. It's actually, I think it's one of the pinned issues. You can see though, and I think this is what's most important, is understanding where a technology is going requires understanding the themes that live in the roadmap. And for us, those themes really live around getting data in quicker, insertion, reading, ease of use, etc. Some of these have PRs, some of them are already implemented. It's just a list, as I said. The slides will be available. One of the things I say a lot, and I think Zach in the back actually agrees with me on this one, is that a database in isolation is interesting, but meaningless. When a database becomes meaningful is when you put data in it and you build an application around it. That's what makes a database interesting. We could talk about consensus, we can talk about implementation. I'm more than happy to do all of that. But what really matters is what Shopee has done, is what others are doing. That's what makes ClickHouse interesting, is the really cool list of things that people build around it. And of course, once you get that data in, it matters a lot that you have the opportunity to manipulate that data as well. And then finally, sort of more flexible analytics. Our support for the new analyzer that we just built by default, continuing to extend joint support, indexing, and search. And this is perhaps, I think, what's most important. We release in open source every month. At the end of every month, we have a call. We then write a summary of that. We call it our release call or our community call. It generally is not a great time for you in Singapore. My apologies for that. But it is recorded and put on YouTube as well. And our open source release actually leads our cloud. So the other question people ask me a lot is like, hey, Tyler, how does ClickHouse, the company, make money? The way that we make money is when you don't want to run ClickHouse on your own, we have a way for you to do that, and that's ClickHouse Cloud. So let's talk about some of the new features that are coming out in 24.8 and 24.9. Again, I'm not going to go through them all in detail. I'm just going to pull out a couple of really interesting ones. The new Kafka engine is one that I think is super cool. The Kafka engine has existed in ClickHouse since 2017. It's a way to implement streaming consumption and data pipelines from Kafka. The downside to that is that there was no support for atomic commits from Kafka to ClickHouse, which means there's the possibility of duplicates. Now there's actually an opportunity to manage the offset from the stream directly in ClickHouse Keeper. ClickHouse Keeper is a rewrite of Zookeeper to address the problems that we found with it. You set it up a bit like this, set allow experimental Kafka offset storage in Keeper, kind of extraordinarily long but descriptive names. And as you create your engine, that's what you would change. And we no longer rely on Kafka to track the offsets or manage Kafka services like Console Cloud, etc. Instead, the offsets are actually stored directly in ClickHouse Keeper, which means that there is the support now for deduplication, and in most cases, and it's still experimental for a reason, because we encourage you to try it and tell us where it is broken before we bring it into beta and then make it GA, that we can actually support exactly once delivery. In addition, we've added a time series engine. You'll notice that it also has the lovely little experimental flag next to it. I'm sure there's a better way of showing experimental, but it's one that worked for me last night as I was tweaking these slides. So we support 4 Prometheus protocols, both remote write and remote read, and it implements storage for metrics. Basically, fundamentally, what you define is in your Prometheus file, in your YAML that defines Prometheus, you define the endpoints that you want to go to, and then ClickHouse is listening on the Prometheus protocol, and it's ready to receive your metrics. And it's great, and we have some people who love it, who are using it in relative anger right now. The next work is to actually support PromQL, so that you're able to integrate more tightly. Here's a fun one, overlay. This actually came out in 24.9. Does anyone here know the overlay function in SQL? Cool, me neither. I had no clue that this existed. So select overlay, hello world, test, you give it the offsets, and then you get hello, test. And you may be thinking, Tyler, who cares? And that's a fantastic question. I'm not sure. But the person who cares cared a lot. And they cared enough to actually contribute this to ClickHouse as a member of the community. When I said that ClickHouse speaks SQL, I mean that it speaks SQL. We have support for things like SoundX, which is a deprecated protocol from SQL Server in the late 90s, which is when I first started as a SQL Server DBA. I remember when it was released in SQL Server 7. I'm getting a nod over here, which makes we feel like I'm all alone, which is important. It's good to feel like you're part of the community. There may be a visualization tool that expects support for overlay. Because we have broad NC SQL support, it also means that our ecosystem of 175 plus integrations are able to work as well. I mean, to be fair, you could do this using a whole bunch of substring and concatenation logic, and it would work as well. But why would you want to do that when you can just select overlay? This one is near and dear to my heart. This is actually where I spend the vast majority of my time in ClickHouse, which is hey, I'm back. Which is with ClickHouse Local. And so in this case, I have a challenge. And the challenge is, who is a new contributor in release 24.9? So what I do is I call a quick sudo command for Docker to run 24.8. I open up ClickHouse local and I run a query. Select star from system.contributors. The system contributors table is where every contributor to ClickHouse is listed. Alexei, our CTO, and the person who wrote the first line of code in ClickHouse, about a decade ago, gave a talk at a GitHub event. And he was asked about the system contributors table and why it exists. And he said, I want you, as a contributor to ClickHouse, to be able to go to any company in the world, and when they say, have you done any work that I know of, say, open up ClickHouse, run a select on the contributors table, and you'll find my name there. This is deeply important to our identity as a company. So now I have a list of everyone who contributed to 24.8 in the text file. So I run it again, and I get a list of everyone who's contributed to 24.9 in the text file, even though I just noticed it says 23.9. And then I'm able to use ClickHouse local, which is an ephemeral instance of ClickHouse, all in memory running on my local machine, to do some simple array comparison. And to say, I want a list of everyone in 24.9 who is not in 24.8. And in fact, this is the list. And if your name happens to appear on this list, I've got a rad ClickHouse contributor sticker to give to you that we only give to people who show up in that system contributors table. And this is something where I use ClickHouse frequently to actually do textual comparison and analysis. It's not what you think of when you think of the canonical billions of rows, but it's a way where ClickHouse daily makes my life easier. JSON object format. I'm going to go ahead and tempt the live demo gods for a second. Let me stick this in the mount. And so it's further away, so it doesn't sound quite as good. I'm also so many years old that I have to take off my glasses in order to see what's on the computer. So apologies for that. So the JSON object format is an experimental format where you have the opportunity to actually ingest JSON data, analyze that data, and infer the data type for every path. So you have the opportunity now in ClickHouse to enable column-oriented storage and queries on arbitrary semi-structured data. Let's look at it because that'll be fun. So here is ClickHouse, my local ClickHouse instance. By the way, if you ever want to download ClickHouse, just curl clickhouse.com, pipe it to a shell, and if you execute that, it will grab the most recent build off of master. So like what lives on head at the moment, and download it to your local machine based on your user agent, etc. So it should, in most cases, give you the right version. So let's start here. I'm going to go ahead and I'm going to launch ClickHouse local. As I talked about, this is the local instance of ClickHouse. This is where I would do that comparison that I've done on the last slide. So ClickHouse local is right here. I'm going to go ahead and I'm going to set the experimental type for JSON to 1. You'll see also, let me pull it up real quick. I have a zip file. It would help if I could spell ClickHouse correctly. I have a zip file that lives in this folder as well called master. And master is a zip archive of relatively unknown size that represents the data from football matches in Europe. So I'm going to do a quick select. I'm going to use some lovely little regex. I'm going to use from file. So I'm actually selecting from the zip file itself right now. I'm looking at these JSON files. I just want to get a sense of what data is in it. All right, so I've got a long string of JSON that's relatively impossible to read. I could probably save this off, pipe it to JQ or something, and get a better sense of the structure of the data. But because I pre-prepared the demo, I know enough about it to say I'm going to create a table. And I'm going to have a match ID as a string. I'm going to have JSON,
And then my ordering key, which matters a lot in ClickHouse, and we could talk about that later. If you were in the training today, you probably have some information about it, is going to be the team ID. And I'm gonna materialize that team ID. So I've gone ahead, I've created my table. I can actually use that exact same select that I used before and flip it into an insert. So insert into events, select from, and I'm gonna let this run for a minute or 2 or 3. I'm honestly not sure how long it will take, but you can see that it's going quite quickly. And of course, the first thing I'm probably going to want to ask when it's complete is like, how many events did I just insert into this thing that's running locally, ClickHouse local? I could use this exact same syntax if I was running ClickHouse as a server, if I was running ClickHouse in the cloud. I could use it via CLI, etc. So we're at about, 5.5 million rows. I believe it's 12 million and change. So it should take just a little bit longer. One thing that's worth noting is that insert statement. You can't actually make a nested field in JSON, the sorting key for the table at the moment. But that's a feature that's planned for future versions. So for now, I just created that materialized column. We're gonna let it chunk through this a little bit longer and see how it's going. 98%, that's always a good sign, right? This is the joy of the live demo, is that, to be honest, I really have no clue how long, 75 seconds. So 12 million rows inserted in 75 seconds, running here on my local laptop. Let's see if that's actually what it was. Select count, yep, select count. Select count is, it's not what ClickHouse is designed for, right? It's good, it's a good way to see what data is available, but usually you want like select average from thing during a time frame. You're really looking at aggregations rather than simple counts. So now I'm gonna use this new format. I'm gonna use the JSON.syntax, to find the most recent, the most frequent events that sort of scrolled off screen. There we go. So 0.158 seconds, 8.5 million rows. The most frequent thing that happens in a football match is a pass, which is not surprising. It's part of the reason why I don't watch a ton of football. The dot syntax, it's super useful when you want to read a literal value. But if you want to read a nested value, you'll see now it's like JSON possession as team. It comes back as a null. Gross. So instead, there's a caret syntax, dot caret. So now I'm going to do this select JSON dot caret possession team as team. And here I can see the JSON string. Okay, Barcelona was the folk who passed the most by a large number. And then after that, we see Paris Saint-Germain, Arsenal, Bayer Leverkusen, etc. Also, I just want to show you the notion of dynamic types really quickly. So that team name, if I'm selecting just the team now, when I talk about type inference, I can use the dynamic type of team as team type to show me what ClickHouse has inferred for that type. In this case, it's a string. Or for the duration, it's inferred as a float 64. This is also experimental. If you're using ClickHouse, if you have a pile of JSON data, play with it, tell us what's awesome, tell us what's terrible. We'll continue to iterate on it and we'll make more changes over time. Oh, cool. One other thing I want to show, let's see how the Wi-Fi is here, is saved queries as APIs. So I'm actually going to open up ClickHouse Cloud real quick. Let me maximize this. Log in as myself. It'll take just a moment because Wi-Fi is indeed a thing. So I have this service called Sensors that's actually running here in Singapore that I've loaded some data to before. This is SQL Console. The SQL console is incredibly powerful because it gives me the ability to interact with my data in this sort of visual format. I've got a very simple query here called, just select hello world as test, right? So this isn't actually touching any data. All it does is throw back hello world. But I've saved this query and I've turned this query into an API endpoint, which means that if I know that this is a query that I'm going to run a whole heck of a lot, let me, pardon me, exit ClickHouse local, which means that everything that I just imported is now gone. I'm gonna go ahead and clear this real quick. Clear. Oh, here, this is fun, CLS. I just typed the wrong thing. I just installed this. Fuck. And no, I don't want LS, and well, that didn't work. It doesn't want to give me the one I want. But yeah, it's a great way when you constantly type the wrong command to use an extension called fuck, which reminds you of what it should be. So here's my curl, where I just curled that API endpoint that's running in cloud, and it gave me back the test hello world. Similarly, if I come here, I'm actually able to see the insights that have come from it. And oh, there it is. That was me just now running that query. You can also save a whole bunch of queries as saved queries. This is UK property price data that I put the wrong information in. So I'll click the fix query button. Fix query is a thing in SQL console where it actually uses, there it is, AI and LLM to look at your query and be like, here's likely what you did wrong. So you can see there that it told me you need to run it from pp underbar complete instead.
Select the top line.
Yeah, but I've got it now, I just fixed it. But it told me what the error was. So this is, as I said, UK price data. I'm just getting a format readable quantity, 28.9 million rows. This is an estimation of how much space that takes on disk. So you can't see it back there, but it's 240 meg. I also have the ability to do fun things like, cool, I want to run a query and look at price over time. And this is a great way, using the function bar, to actually graph that. But because it's SQL console, I can just drag the column names from this query around and get a lovely chart of what's happening. So this is ClickHouse Cloud. It's ClickHouse running in the cloud. Also, just one thing that I think is very fun is someone who will remain nameless sent me this yesterday. They were on a long overseas flight to come here to Singapore, connected their laptop, and this is SQL console running on a plane in the cloud, which may be the bougiest thing ever, but I'm kind of in love with that photo. Couple of other things we're doing with ClickHouse Cloud. We're working on BYOC, bring your own cloud. Not just, I talked about the distributed nature, sort of compute from storage separation, but also compute from compute separation, so that you can define node groups and begin to optimize workloads based on what they look like. So that's right at 20 minutes, which is what I was allocated. I should have only taken 15, but I ran a little bit long. I want to thank you all so much for being here.